So let us go to the last presentation in today's session. It is on civil engineering construction. The presenter will be Engineer Prabodha Jinasena from CCB, Central Engineering Consultancy Bureau. He is Additional General Manager. He will be presenting Introduction to Skeleton Bridge Abutment. Let me give a brief introduction about Engineer Chandrasena. He's a chartered civil engineer by profession, attached to CCB as the additional general manager, and he's the in charge of airport and road design division of CCB. He has more than 30 years experience in the field of highway engineering, and he was a design engineer responsible for highway and bridges in Mahaveli Rajamawata from Adhikaram Gama to Mapakada in Sri Lanka. He has made presentations on the theme Introduction to Skeleton Bridge Abutment at engineering organizations and also at the Institution of Engineers Sri Lanka. He is presently the chairman of Civil Engineering Sectional Committee of IESL. Mr. Jinasena won the Chartered Engineer Excellence Award 2014 presented by the IESL. Congratulations, Mr. Chandrasena, it's your floor now. Mr. Jinasena.
Good afternoon. Thank you, madam, for your kind introduction. This is my own experience years back. Skeleton abutment, you would have traveled on roads, bridges, but what this is? Let's have a look at it. Bridge. In highways, you find bridges. What is the definition? I don't want to make it too complicated. I'll try to make it very simple so that non-civil engineers could understand this. So this is the basic definition of bridge. It's a structure that provides passage over an obstacle. What is the obstacle? It can be a deep valley, a river, or a roadway. So bridge has two components. One is superstructure, the other one is substructure. What is superstructure? Superstructure is the part spanning the obstacle. What is the substructure? The part that holds the superstructure. So in this, went further down. Right. This is the superstructure. This is the substructure. So basically you can say anything above bearing pads. You find the bearing pads here. Anything above the bearing pad, superstructure, below is substructure. So what are the components in the substructure? It has end supports and intermediate supports. So end support is called abutment, intermediate supports are called piers. So let's compare pier versus abutment. What are the differences? The main difference between pier and abutment. Pier supports the vertical load from the bridge deck, and abutment supports vertical load as well as horizontal forces from the embankment film behind it. So that is the main difference. So what are the functions of bridge abutment? Let's look at the functions. Bridge abutment supports the bridge deck. Transfer the load from the superstructure to the foundation. Retain the earth fill behind it. And basically, in most of the abutments are constructed with wing walls to support the film material. And it serves as a retaining wall. Basically, it is a retaining wall up there, right? So I would like to pay your attention to this. Serves as a retaining wall. So that is the point I am targeting at. So these are some of the structures, abutment structures constructed with wing walls. Various shapes of wing walls is angled, right angle, in line with the abutment, right angle, another shape. So there are various types. So what are the main forces acting on the bridge abutment? Now you can see this vertical force is coming from the bridge deck, and this horizontal force is basically due to the braking of vehicles on the bridge deck. So there are two forces, horizontal and vertical, from the bridge deck. Now if you see the back side of the abutment, you have a soil fill that makes the approach to the bridge that has massive horizontal force. Now if you look at that pressure diagram, it has a rectangle component and a triangular component. Rectangle component represents the surcharge pressure, and the triangle is due to the earth pressure. Now it is a linear variation. You can see the equation there. Pressure is equal to Ka gamma times H. H is the height. So it varies with the height linearly, right? When the height increases, pressure increases. It will be a massive force for a tall abutments. When the abutment is tall, what will happen? It has to support massive backfill earth pressure. And to support a massive backfill earth pressure, you have to have a massive structure. Base width is so much. The relationship to the height to the base width is something like 2/3. So it will be a massive structure. Then to construct the massive structure, you need a lot of material. The other thing is the point here. But the load transferred to the foundation, whether it is tall or short, is same, right? So it becomes more or less a earth retaining structure. So when the height is large, it becomes a earth retaining structure. So what is this? I was thinking about a kind of a structure that will not basically support the embankment, but support the bridge structure. What is that? Then answer is skeleton abutment. So what is a skeleton abutment? It's a concrete frame structure. It supports a bridge deck. Backfill material is not retained. It is buried in the embankment. It's also called as open abutment or spill through abutment. What are the components in skeleton bridge abutment? It has a base slab, tapered columns on top of the base slab. Then you have the capping beam sitting on the two columns and the wing wall. Very short, very small wing wall. So this is the three-dimensional view of the skeleton bridge abutment. So base slab, two tapered columns, and the capping beam where the beams are sitting on. Then how the fill material of the approach is retained. What is the mechanism? Let's look at that. Abutment is buried. You fill up everything and maintain a stable slope in front of the abutment. So material is not retained by the structure, it's retained on its own. Then you get water there. That water can erode the embankment. So how do you stop that? Riprap or boulder pitching. So that is the mechanism. So these are some of the bridges I have designed and supervised. If you travel to Mayangana from Kandy on Mahaveli Rajamavata, which is on the right bank of Mahaveli, you can find these 5 bridges. All these bridges are having skeleton abutments. So So I will show you some of the pictures during construction. These are the two columns at that particular location under construction. This is the complete structure. Then after launching the beams, you can clearly see there, material is not supported. It is coming through that. That is why it's called spill-through abutment. Then, after the filling, you can see a natural slope is maintained. And this is Bellyhulla bridge. After Diabukola, you find Bellyhulla bridge. There also you see the natural slope and riprap. Then Kurundoya bridge after that, same thing, but the stream is dry now, which was taken. This is Ubaoya bridge after that, and this is the last one, that is Badulu Oya bridge during construction, right? You have the two tapered columns, that is a pier, and soil filling is going on over here. Then is almost nearing completion, Badulu bridge, which is the last one on that stretch. And this is applicable, or this can be applied in expressway application. Expressways also. Abutment over there is hidden, can't see it. So let's see the advantages of this particular abutment. Structure is lighter because it doesn't have much material. It's a skeleton only. So earth pressure on the structure is minimum. Expensive wing walls starting right from the bottom are omitted. Comparatively, abutments are short because it is pushed into the embankment, so you don't have to have tall abutment standing right at the edge of the stream. Stream flow is not blocked. It is because it is pushed into the embankment. So it is a better solution for steep banks. So let us look at the disadvantages. These are the disadvantages. You need space in front of the abutment to have natural slope. Soil compaction between the legs is not so easy. You have to use light material, light equipment. You can't use heavy equipment. So it takes a little time. Construction is cumbersome because the columns are tapered and kind of thing. And span, when you compare to conventional abutment, will be little more. So what are the deciding factors? Let's look at the deciding factors. Shape of the valley, bearing capacity of foundation material, hydraulic data. If you have very turbulent flows, this may not be suitable because it can erode the embankment, whatever the precaution you take. And the cost comparison, because when you have it, spans will be little more than conventional. So you have to do a cost comparison and see whether it is economical. Just look at this. This is how I did it. If you do what you have done, you will get what you have. Do things differently to get different results. Think differently. This is why the conference theme is very important and appropriate today. I love a few words on the theme: education, research and innovation. But I would like to add one more word to this. Can anybody guess? Can anybody read my mind? Training and development. Thank you.